Okay, Austin, you can start.
All right. Hello, everyone. Thank you, especially those of you who are staying up late to join this. I appreciate you all hopping on. Hopefully this is going to be interesting. I think this is the functionality of what we're going to talk about today is incredibly important for the future of the internet computer. And the certified variables part of it is very interesting from a security standpoint. So I hope that if nothing else, this will be interesting and maybe make some things occur to you that hadn't occurred to you before. My name is Austin Fatheree. I do a few too many things. I just want to give a brief introduction to myself. I've been sort of exploring the IC ecosystem with enterprise customers since late 2017, which is, it only was released last year. So I was recruited to help launch a company that was going to use DFINITY back in 2017 when we thought they were going to launch. And so it took a while for that to actually happen. But in that interim time, I spent a lot of time talking to the DFINITY engineers and really trying to understand what the system was going to be about. And then once the system launched, I started programming it and trying to use it. I am currently the executive director of icdevs.org, which is a US charity that's focused on education and scientific discovery around the internet computer. If you've been on the forums, you may have seen some of our posts, some of our bounties. I'll talk more about that later. But our current goal is really to raise money to inject back into the community through forums that help educate developers and expand this ecosystem. I also act as a CTO of a company called Origin Foundation. Origin Foundation is a company that's developing on the internet computer, and we are building sort of digital twin / NFT / certificates of authenticity, whatever you want to call them. Basically, these things that link real world objects to digitally tradable and traceable goods. I have a project out there, a public project that I did previously called Make Me, which was a NFT / attempt to get around the Howey test by using distribution licenses. That went horribly wrong for me, but is still an interesting thing to check out if you are interested in learning how to mint and NFTs, those kinds of things. I think you'll have some exercises around that. I've seen some other presentations, but if you follow that trail, you'll find some source code and the way that I went about it and the way I implemented it, including charging for them and things like that. I also have another project that I did a DFINITY grant for that's on this list that was around image manipulation and putting media on chain and manipulating it on chain. So those are kind of all the different things that I've had my fingers in with the internet computer, and I'm super happy to be able to sort of try to help you all with what you're learning, so that you do not make some of the mistakes that I made and can continue to contribute to this ecosystem. If you have any questions, please put them in the chat, and I will try to answer them as we go along, or Dukakis is going to interrupt me when appropriate. So let's get started. Most of my there's a few slides, most of it's code, and just talking about code. So hopefully that will be instructive. So let's talk about HTTPS and certified content. The IC has an HTTPS endpoint for every canister. So for every canister that you create, especially for your asset canisters, but also for your code canisters. They can serve HTTP as a website from a URL. Typically, that URL looks like HTTPS canisterid.ic0.app. And then whatever you want, you get to define it. You can serve all kinds of files from this endpoint as long as they are certified content. This is, and I'll tell you what certified content is in a minute, so don't stress out about that too much. This is query only for now, which means you can't update anything from the HTTPS endpoint yet. There are some things in the works, I believe, and if you use the ICPX or ICX proxy that actually comes with the DFX, it's kind of hidden in there. There is some functionality coming where you can upgrade certain requests to update requests via an HTTP request update function. But I don't think that that's made it into the core protocol yet. And when it does, that will be nice because you can then make changes. If you're familiar with HTTP, what this means is that right now you can only do GET requests via the HTTP interface to your canister. What this means is that your NFT collection can host its own website. I know y'all have been focusing a lot on NFTs right now. You can, by the end of this, have a good idea of how to host a website that hosts your collection, or maybe even sells your collection if you get very, very ambitious. On the certified asset side, you can sign your content, and that lets your users know that it wasn't faked. It means that your smart contract signed the data and included the data in a Merkle tree structure, which we'll see something about in just a minute. But basically, blockchains are generally these giant Merkle trees, which you can imagine along the bottom of a it's really more like roots, right? At the end of every root is some data, and they all roll up to a magical number through cool math. And if you take the root and the tip and do a proof along that, you can prove any of those items at the root are part of the set. And this is cool because it means that people can take your certificate. What it means is you can take the root of the internet computer, and if you program your smart contract right, someone can prove that the data they have was part of your canister and served from your canister at a particular time, that it was a valid piece of data in the data set. So if you have an append-only data set like Ethereum, you can prove that a transaction in the past definitely happened, right? Or in our case, where we look at today, we can prove that a piece of content is officially endorsed by our smart contract and a part of our smart contract. And having that certificate means that the whole network agrees that that's your data. If you want to, you don't have to use the certified data. In fact, if you guys have used Discover One at all as a message board, when you go to that URL, it redirects you to a URL, and it has this word raw in it. And so you get canisterid.raw.ic0.app. And that raw lets any data come back across the HTTPS interface. So for Discover, they serve up their website via that because certified data is not easy. It can cost a lot of cycles. And so typically you only want to certify things that are really, really important in the long term. So This is going to make a lot more sense once we have some examples and I show you what's going on. But right off the bat, does anybody have any questions? I don't see any in the chat, so I'll keep moving forward.
Yeah, go ahead.
Okay, so first thing I want to do is I want to credit Joachim Bretner, who created the base project that I'm gonna modify and do some things to. This is where you can go get that. This presentation is in the lecture materials on the Google Drive. I don't know if these guys have access to that or not, but hopefully so. And somebody can direct them there if they want to download the presentation. But I'm gonna cut over here, and we're gonna go to our wonderful Motoko playground. I hope you guys are fairly familiar with this by now. I'm going to walk through the code. Please inject into chat if something does not make sense.
Is someone recording? Duke, are you recording right now?
Sorry, Zach, what are you saying?
Are you recording the meeting right now?
No. Yes, I'm recording the meeting. Yes, no, I'm recording the meeting. Yes.
Okay, nice. Cool.
Okay, this says record to cloud, record to computer. Are you sure it's being recorded? Because you handed me the host. Did you hit record before, or do we need to hit it again?
Yes, I did. Don't worry.
Okay, cool. All right, good. So the first thing I'm going to do is I'm going to click deploy here, and we are going to install this and let it install what's here, and I'll show you what's going to happen here. Okay, so we've got this canister. We've got our candid UI over here. We'll let it load up. Oh no. Did I put the wrong one in? Interesting. Nothing like a live demo. We'll try one more time. Okay, there it goes. So the default didn't work for some reason, but once I put a message, it's worked. So what is this doing? I'm calling the canister, and it is returning back to me. This canister demonstrates certified HTTP assets from Motoko. You can see this text, and it gives the URL, no raw, and it will validate. And this demonstrates that this really is dynamic. You can leave a message and it gives you the IC rocks. If IC rocks is up, you can do that. The last message submitted was test. Now, when you hit one of these URLs from a URL that does not have raw in it, a couple things happen. And I'm going to describe this, and it may be wrong, but this is how I understand it, and it sort of makes sense to me. There is something called the service worker. And when you hit this, when you hit this HTTP endpoint, it's going to return back your message through the usual pipes that are the internet. It's a series of tubes, right? So you get the message coming back. There's a header that comes back, and one of those headers has information in it that is a signature and a certificate that the data coming back was signed by the internet computer, and specifically by your smart contract. The service worker looks at that as it's passing through, and if it doesn't match, it says, no way, I'm going to send back that whatever it said earlier before I sent the message that we couldn't verify the content. I am not going to serve this. You're not trustworthy. So that's what's happening here. So what's going on? Let's go into the code. We're going to start off. We've got a function called leave message, and you saw me put test in there. If I put test 1 2 3 and call that, it's going to call this leave message, and we are going to change the message to whatever that text is, and then we're going to update our asset hash. Now, since I did that, if I go over and hit refresh, I should see test 1 2 3 instead of test. What is update asset hash? Well, we're going to serve up a page, right? And this page here, in this case, is just text. Here you can see the main page. I'm outputting, I'm encoding this as UTF-8, and I'm outputting this text where I show my ID, which is my canister here, and then I put the message at the very end. So this is the function that produces the quote unquote web page. In this case, it's text. So to serve this HTTP asset, every Motoko canister, and Rust has this as well if you're into the Rust, you have this function called HTTP request that every Motoko canister has. And it takes this object HTTP request, which is pretty straightforward. You basically have the method, which is get, put, update, delete. I guess you can theoretically pass a put, update, and delete currently, but they get treated as a query. You can't update any data. They're just a query function. So it's like you can only do get. There's the URL. So you get past whatever is in that, whatever's after your slash. And then you have your HTTP headers that come in. So if there's any authentication headers that are passed over, if there's any, and I think that there's actually some cool ones that the service worker adds that tell you where the request came from, that you can look at as well. And then you have the body that is a blob. This function looks for that structure, and then it's got to return a response. So the response is your typical HTTP status code, 400, 404. You can do 404 and serve your fail whale or whatever. But I think 200 is what we want, right? 200 is a success. Then you have to add these headers, and then you pass your body back as a blob. So we can see that happening here. So if it's get and we're serving the root, we're going to say status 200, add these headers. This is a text plain header. This content that we're going to send back is text. And the certification header is a function that signs it and tells the service worker, I certify this data, I'm going to pass it through. And then the body that I'm going to send back is just the main page, right? Pretty simple, right? Otherwise, if you ask for anything else, I'm going to say, no way, 404 error, not found. So if I go up here and I try something, not only does my body not pass, not only should I get a 404, but the body doesn't pass verification. So that is that. Let's see, I see a question. I don't follow you on certified assets. How do we know that they are original? I will explain that in the future, I promise. I should have used, and you're right, I should have used raw, and I'll do that in the next example when we load it up, and you can see how that works. Okay, so how do we certify the asset? How do we produce this certification header? We are going to use something. This is actually defined here at this URL. So if you want to know how all of this works, you can go into smartcontracts.org/doc/interface spec and look for certificate. And this is the actual specification for the internet computer, and it tells you how to do this. A certificate is made up of your hash tree, your signature, and whether it was delegated or not delegated. I am not going to go into delegation during this discussion. Someone else will have to tackle that, but I think delegation is used maybe with internet identity. I think it might be important there. So here we have a hash tree. Think of a hash tree as it's like a binary tree if you're into computer science. If you don't know at all what I'm talking about, just imagine a lot of times these are used in searches, and you start at the top and the left goes to you can check whether your value is greater than or less than a certain thing at the top, and then you can go left if it's greater than, or right if it's less than, and that helps you rapidly find a search parameter or find a value without having to look at all the values, because you have in this tree structure. You only have to go down each level and navigate the tree. That's kind of what we're doing here. You're going to have either an empty tree, you have a pruned tree. A pruned tree is pruned means that you've hashed, so you have two values, and value A has a hash and value B has a hash, and then the matrix point is the hash of the two values. So I'll actually bring up you've probably run across this if you used a hash map. Typically this article has really good data. Merkle tree, there we go. So it looks like this, right? You've got all your values at the bottom, and a hash takes a very large piece of data and creates a unique ID for it. Typically you use SHA-256 to do this on the internet computer. Ethereum uses KCAC or SHA-3 to do this. And you take a value, and that produces a hash, and then you can hash those two together, hash of 1-1 and or 1-0 and hash of 1-1. And so if I want to know that L3 is part of this, I can just navigate this, and I can prune this. And so you can imagine if this gets very large, you can save a lot of search. So this is the definition of our hash. There's actually we'll actually look. There are a couple Merkle tree modules out there that you can use if you don't want to build this from scratch every time. So pruned means we've cut off 1/2 of it, and we just have a hash on that end, and we're going to keep navigating values the other way. A fork means that we've got two values. Label is like a key and a hash. So at the top, you basically have these labels, and that's defined in the specification as well. And then a leaf has your actual value in it. So Joachim says, the undocumented interface. Basically, I think hopefully they've documented it now, but our asset tree at the top has to have HTTP assets. So the service worker is going to look at the tree that's passed in and look for HTTP assets. And then under HTTP assets, it's going to look for the URL. And if it doesn't find a value, if it doesn't find that item in the tree, it is going to it's going to throw and show you that cannot certify data. So this is our asset tree. It's really simple because we have one message and it's only at the root. We need a leaf at the bottom of our tree that is the hash of our content. So we take all of this main page, all of this text gets reduced down to about 256 bits here using this H function, which is a hash. And it's at this place in the URL, and then it's HTTP asset. That's really most of what we're doing. The other thing we're doing, when I leave message, I call update asset hash. And that's what's happening down here in update asset hash. I calculate the asset tree, I pass it into a hash tree, and I use certified data.set. Certified data is a system function that you can load in and you can import certified data, Mo-based certified data, and it lets you sign data. And every time you update, this is why it can get expensive to do certified data. It's no big deal when we have one value, but if we had 1 million items in our tree and we wanted to update one of them, we would need to update the certified data root at the top of our tree and tell our canister that every time. I will answer, Andres, that's a great question. I will answer your question in just a second. What does our certification header look like? This is, we added that certification header. This just returns IC certificate. This is the key, and the value is certificate equals this and tree equals this. Now, Joachim says something very interesting here. This is a CBOR and base 64 encoding is involved here. Motoko doesn't have a CBOR encoder right now, and so Joachim wrote he wrote something in here. He started this. Now, for IC devs, we actually have a bounty for someone to write an official, real, complete CBOR encoder because it's going to become necessary as we look at Motoko wallets and things like that. But this is the beginning of what that looks like. And CBOR is just a binary encoding of data. So if you think about JSON data and you think about converting that into binary, that's kind of what CBOR is. And I don't know why. I think because of its efficiency, they decided to use CBOR as the encoding mechanism instead of JSON. So so when you write this thing out, when you write this header out, you have to do all of that. You gotta take the asset tree and you gotta CBOR tree it, and then you gotta convert it into base 64 and return the tree. Now, as far as he notes here that a more serious implementation would not return the full tree. So what's cool about this is once you have this whole tree, when you're returning your value, you only have to pass back the path to your value that you're returning. So the service worker is going to look and see if it can navigate from your one value up the tree, but it doesn't have to know the whole tree. It only has to know the path up to the top. If you do some research on Merkle trees and how they work, that will eventually make more sense. But that's what's going on here. So we're cheating a little bit. And I don't like it when examples cheat and only go halfway. So I'm gonna try to give you some pointers to how you can do this for real by the end of this lesson. So that's the end of demo number 1. Andres asked about encoded images, which I'll answer in a minute. Are there any other questions, or does anybody have any questions about these functions and want to look at any of them more in depth? What if you don't have an even number of blocks? This is interesting too. Your tree can be very lopsided, and as long as you provide a pathway that leads from a value to a root, you're fine. One end of your tree could have, 500 levels, and the other end could have 4. And as long as it matches, it matches. So you just have to have a proof. It has to be a proof all the way up to the top. It doesn't matter how deep they are. This is maybe a little off topic, but Bitcoin is basically like a big hash tree. Except at the end of each node, you have UTXOs, unspent transaction outputs. And when you spend a Bitcoin transaction, you actually split this down. So if you were to really look at the UTXOs for Bitcoin, you would have like a very unbalanced tree where like Satoshis would like not be split. They've never been spent. And then, the pizza guy who sold his have been split 1,000 times. And so that tree is very unbalanced, most likely. Yeah. Okay, so that's that. Now I'm going to load up my second example. And we're going to change just a couple things. All right, so this time, mostly same example. I put raw in here, so you can see that it's not certified, and if you have raw in there, it'll serve it anyway. If you take the raw out, it won't serve it. So what have I changed here? Well, we still have this last message, and that's kind of the default. But I've added a tree map here, which has a text to text. So this tree map is called pages. And I have a function called add pages where I pass in a path and I pass in text. And when I call that, I put that path and text into my pages, and then I'm going to call update asset hash. So I'm going to do that before I go look at update asset hash. And I'm going to pass in /test. I'm going to put in test 1, 2, 3, 4, 5. Oops, that's the wrong function. Add page here. Now I have at /test, I am sending down this text and it's certified. I can go back and I can add and now I have pages. I could do Now what happens if I do I haven't coded in raw HTML in a while, guys. I hope I'm not making a horrible mistake here. That doesn't look quite right, but it worked. It served it. So why doesn't that look quite right? We'll explore that as we keep going. So how did I change this? How am I certifying multiple things? Well, I have this update asset hash. Here's main page, which is sort of the default, but I updated my HTTP request function, and I switch on, or I do an if statement. And so I say, if the URL is this, then just serve up main page. Otherwise, I'm going to go get out of my tree map, I'm going to go get my URL. And if I find nothing, I'll return 404. But if I find a page, I am going to send down the page, the content of this page, and the certification header. What's the certification header? I have to send down my asset tree. So here I'm kind of cheating here. And somebody asked about unbalanced trees. I'm cheating here by making an unbalanced tree. If the page size is 0, then I just do what I did before. Otherwise, I'm constructing a very unbalanced tree. I set the last entry to the root, and that's the main page. And so this is a little bit functional if you're into functional programming. I start with the bottom one, and then I'm going to loop through every entry. And for every entry, I'm going to stick that item at the bottom, or I'm going to create a fork. I create a fork, and I put the last entry at the bottom, and then I have this one. So what I end up with, if a bunch of pages, I have a very unbalanced tree where it gets very deep. So this would not be an optimal tree to build eventually for whatever that last item is, but every one is a fork, and then the next one's a fork, 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 all the way up to the top. So the left-hand side is very shallow, and the right-hand side is very deep. And that's all I do. And then at the bottom, what I return is labeled HTTP asset, and I put whatever that last entry was. But otherwise, everything's the same. And so I can keep adding pages and content, pages and content, pages and content. So one thing to notice here on HTTP request is that when I return this back, I'm returning back whatever page I find with a content type text plain, right? So that's that. That's the second demo. Any questions on the second demo before I wrap up on the third demo? All right, cool. So let me pull up the third one. We will deploy. should pass. Something's wrong with the main. I don't know why the default's not working. Somebody could find my bug and send it to me. So I've done something a little bit different here in this third example. Pages is now text and a content type. So all I did was swap out, instead of text to text, it's text to page on tree maps. So hopefully you guys have run across tree maps by now. We are going to, we changed add page. So now it takes text and a content type. And everything is pretty much the same. So let's create an example. This is going to be a boring example. That works. Now let's do something a little more interesting. So now, what did I inject in there? Well, I basically put, let's find the best way to do this. I put in an SVG, right? And I told it to serve up SVG. So everything else, the calculating of the asset works the same because I just put in text. And I'm serving up this SVG. It's not a very big SVG, but it works. So the answer to could you do base 64 encoded images is yes, you can. If I were to put, if I had an image base 64 image, I could put it in here and I could put image / PNG and it should theoretically serve it up and you should be able to view it. So that is super cool. Now for Motoko, the thing that I would warn you and something that we're running into and something that we have a bounty for is that you can run out of cycles calculating a hash over a very large file. So if you have a massive image or you have a movie, you're going to have to have the facility to hash that over multiple rounds until you get the final hash and can record it. So we actually have a bounty for someone to do that. Quint, if you're familiar with Quint, he's basically done 80% of the work for SHA 256. Someone just has to wrap it in one more piece of code that lets you track the call over rounds. And then it also has someone else to do the KCAC so we can do Ethereum stuff too. But basically that's this calculate hash tree can just get very big if you have, or this hash function down here can get very big if you have too much data. So that's basically it. Let me try. I'm gonna live code something here. Let me see if I can do it. Oh, come on, internet. Well, I was hoping I could find a very simple HTML example that I could just paste in here. But that's not going to happen. Okay, I guess just trust me. These links are in there, so you could go try to put index.html here, paste HTML, your whole HTML file in here, and tell it whatever the MIME type is for HTML, and theoretically it should certify that and serve it. If the HTML file is too big, you might have issues, but it should certainly work for smaller ones. Okay. Questions. Is this server-side rendering? It's not really server-side rendering. It's actually interesting because this interface is only query, you can't really do server-side rendering through the certified assets. Imagine if we had a timestamp in the middle of this file, and it was always different every time you served the image. You have to your update only gets your certification only happens when you add a page. So since it's a query, you can't update it. You can't update in the same call, and so you'd have to wait for the update, HTTP update. And I think they're going to add a function that just looks like HTTP request update, and that one you'd be able to update with and render a custom page, certify it, and then serve it. But it's going to take a lot longer. It's going to take the whole 2-second round of consensus to produce. So it's really just serving up. This example is just serving up the raw asset that you put into that text. Yeah, we're back to SVGs. How would this integrate with the default front end that gets created with DFX new? Great question. So I don't know if that's ever been, if that's open source. I mean, I guess it has to be, but this what we created is exactly what happens when you do deploy and you're deploying an asset canister. It deploys, in that case, it's a Rust canister. It deploys the canister and sets you as the controller so that only you can update the data. And then it starts pushing data in. Now, I'm hearing somebody, I don't know who's, somebody's coughing or something, but and then your DFX starts sending the files, asking the system to certify them. And if the file is greater than 2 megabytes, then it has to chunk it up and send it up in chunks. I don't know if it cheats or not. I don't know if the DFX calculates the roots locally and uploads them, or if the Rust is actually taking the hash when it gets to the other side. So I would have to look at the Rust code and figure out what's going on there. But you could basically create your own shell script that deployed this canister and pushed up your HTML and all of your assets at the proper URL, and you would have a Motoko canister that did the same thing. And even cooler, what I think people should start doing is just merge it, right? Like, why do we have 2 canisters? Just have one canister that implements HTTP request and serves your asset files, and then it also has all of your canister functions. You need 2 trillion less cycles to deploy it. It all uses the same URL, so when you there's this weird thing right now with internet identity where you have you get a principal from the front end canister, but the back end canister, if you were to go to that one, it would be different. So it's just just an interesting thing to think about potentially doing. The benefit to having separate asset canisters is that it works, and potentially space, right? It's a very simple interface. And so if you have a bunch of files, you have a bunch of assets that you want to upload, it sort of takes care of that, and it just kind of works. But I think you'll eventually have some deployment features that just combine them, or some pathways that just combine them, and you can host these host your assets on your central canister if it's you probably wouldn't want to do that in like a very distributed application where you have multiple canisters. If you already have multiple canisters, why not have an asset canister? But if you want to publish a canister like a wallet canister that holds its own interface inside of it, or you want your NFT canister to sort of have its own experience that always travels with it, having an endpoint that hosts its own HTML experience, I think, is a powerful thing that the internet computer can do that no other blockchain can do. So along these lines, I actually just realized I forgot. We have four bounties for IC devs right now that are open. That as a prize for we have more than that for the prize, but the winners of the intermediate section of this contest are going to get first pick at these bounties that have real dollar values behind them. The Dfinity Foundation has funded a bunch of them. IC Devs donors have funded some of them. And there's at least 4 of them that are directly relevant to this. The first one I don't have listed is a JSON URL parser. And so basically that URL, right now, the tools for parsing text in Motoko are pretty poor. And so there's a bounty to create a URL parser that will parse the query string and the, any other data that comes through in that URL. Then, it is there, HTTP request parser, sorry. Then we have the big SHA that I mentioned, where if you want to, in Motoko, want to take the SHA of a very large thing, you need to cycle it over multiple calls until you get to the end of the SHA and you can produce the final value. And then there is a CBOR and candid Motoko parser that will be interesting when you output that CBOR that we looked at the very end, where you have to encode the tree in CBOR to sign it. So what this would ultimately lead to is a parsing tool that you can use to break the branches off and only put a limited amount of data in the header. You don't want to put your whole tree in the header every time like we're doing here. So I meant to have this link ready and I didn't have it. I will add this to the the presentation, but this example here actually has or implements. It takes it implements a Merkle tree that has a solver on it as well. So when you call get item, it'll actually reconstruct. And so this file, merkletree.mo, Joachim wrote this as well. It's a much more fleshed out module. And I took what he did and I just added a function to produce like the restricted proof that you need to pass in. And I'll add that to the presentation. Departure Labs IC non-fungible token. Is that similar, Douglas? Is it similar to what? I've looked at, actually, they have an HTTP request in there, and I think they serve up the asset. So if you look at, I did a little bit of this with the Era Make Me stuff. The source code's out there. So this is the NFT we produced. So if you put mode text, it actually produces, and you inspect this, I actually dynamically produce an HTML page that has the NFT and has the history metadata behind it. This is a Departure Labs style NFT. If you take the mode text off, then you just get the PNG of the item, and that's all done through the HTTP request. Now I'm doing this through raw. I didn't do the certified data here because honestly, when I built this project, it was like 6 months ago, and I didn't even know what the certified data was. But if I went back and did it now, I could probably get the certified data. Actually, I couldn't get the certified data to work because I don't think I could hash these size images without the Big Shaw item. Can you selectively certify responses? Less important or large assets are not certified, but vital assets are. Well, you have the choice to serve it via either raw or not. If you want to serve it through the core URL, then you need to certify it, right? So if you go to a site, what happens if you take raw out here? I actually don't know if assets are. Okay, so it does sort of, the regular one does certify the assets that go up, but you know, you really, I guess your client needs to know if they need to request it via raw or not. You can't really say, you can't tell the service worker, don't validate these URLs. Unfortunately, that would be nice if you could do that somehow, but I think it would break what they're trying to do with certified data. All right. Any more questions?
You guys can.
Was this helpful? Was this helpful? Is there anything that you guys would like to see in more detail next time we do this presentation?
It seems that we don't have any more questions.
Okay, great. All right, well, thank you, everybody. Here's all my contact info. Feel free to reach out to me on these various mediums. I have at least 3 different organizations that I know of who are hiring developers. So once you get done with this, I will be more than happy to talk to you. And even if you decide that programming is not your bag, with IC Devs, we're currently looking for a community manager as well. So if you like this stuff, but maybe decide that it's not for you, and you still want to be in the ecosystem, I'd love to talk to you about particular opportunities there as well. And having gone through this camp would only be an asset in doing that. So thank you all for your time. I'll be around on the forum, or I'm on the forums all the time, the Dfinity forums, and then I'm on the Discord as often as I can be as well. So thank you all so much.
Thank you, Austin.
I see a hand. Who has a hand? Somebody has a hand. Dan has a hand. I'm gonna let Dan talk. Here we go, Dan. Hey, Dan. Ask to unmute. There we go. I think you can unmute yourself and you can talk.
I'm unmuted, but I didn't realize this, but
there you go.
Sorry, I didn't have a question, but
oh, you didn't. Okay.
I must hit the raise hand accidentally. Sorry. Good presentation. No, enjoyed it. Thanks.
All right. Thanks, Dan. All right. I'll see you guys around. Thank you. Let's see. Imagine it's my end. I'll click end. Bye, everybody.